Imagine standing at the edge of a river that has swallowed entire cities. The ground beneath your feet is shaking, and not from an earthquake, but from the sheer weight of 20,000 men working around you, and your emperor has just told you to build the most perfect structure in human history. Right here, on this unstable, waterlogged, flood-prone riverbank. Fail, and you lose your head. Succeed, and your name echoes through eternity. This was the reality facing the engineers of the Taj Mahal in 1631, and what they did next was so brilliant, so audacious that modern structural engineers still cannot fully believe it worked. Most people look at the Taj Mahal and see a love story. What they are actually looking at is a 400-year war between stone and water, and the stone is winning. The Yamuna River is not gentle. Every monsoon season it transforms into a roaring flood machine, eroding banks, shifting its course and consuming everything weak enough to stand in its way. Empires have crumbled along these banks. Structures built by lesser engineers have been swallowed without a trace. And yet this monument, 74,000 tons of marble and brick sitting on the edge of that same river, has not moved. It has not cracked catastrophically. It has not sunk. The question that should keep you awake at night is simple: how? When Shah Jahan commissioned the mausoleum for his wife Mumtaz Mahal in 1631, his architects faced a problem that would send a modern geotechnical engineer into a cold sweat. The chosen site sat directly on the eastern bend of the Yamuna, on soft alluvial soil. Waterlogged, unstable, with almost no natural load-bearing capacity, 74,000 tons pressing down on ground that behaves more like wet sand than solid rock. By every conventional rule of construction, this building should not exist. But here is where the genius begins, because the engineers did not try to find better ground. They decided to build their own. Before a single block of marble was cut, the team spent nearly 2 years studying the river. They tracked its flood patterns across seasons, calculated its historic peak levels, and measured exactly how far the water reached in the worst recorded floods. Chief architect Ustad Ahmad Lahori assembled specialists from across the Mughal Empire, Persia, and Central Asia. Hydraulic engineers, master masons, mathematicians. Together, they made a decision that changed everything. They would not just build on the ground, they would rebuild the ground itself, but the real challenge was still ahead. What happened beneath the surface of the Taj Mahal is one of the greatest untold engineering stories in human history. Workers began sinking wells, not for water, but for strength. Dozens of deep shafts were driven into the earth across the entire footprint of the complex, then packed solid with stone, rubble, and lime mortar. Each shaft became an underground column. Dozens of columns became a forest of stone hidden beneath the surface, capable of carrying loads that the natural soil never could. This technique, known today as caisson or well foundation construction, is still used by modern civil engineers when building bridges and skyscrapers near rivers. The Mughal engineers invented their own version of it in the 17th century, without textbooks, without soil mechanics theory, armed with nothing but observation, experience, and extraordinary intelligence. At the top of this forest of stone wells, they laid something even more unexpected: a massive raft of timber, interlocking beams of ebony and other dense hardwoods forming a continuous platform across the entire foundation grid. And here is the detail that genuinely shocks engineers today. They chose those specific woods because they do not rot when permanently submerged. They actually grow harder and stronger when kept wet. The rising groundwater near the Yamuna would not destroy this timber raft. It would preserve it indefinitely. That raft has been sitting beneath the Taj Mahal for 400 years. It is almost certainly still intact right now, doing exactly what it was designed to do. Let that sink in for a moment. On top of this engineered ground, the builders constructed the raised plinth, a platform lifting the entire complex 7 meters above the surrounding terrain and well above the historic floodline. But here is where most people's understanding of the Taj Mahal falls apart completely. The plinth is not solid marble. The interior is a honeycomb of interconnected arched chambers, deliberate voids built into the very base of the structure. This was not decorative, it was mechanical genius. By removing mass from the interior, the engineers reduced the total load, pressing down on the foundation. The arched chambers redirect compressive force sideways and downward through the walls, rather than concentrating it at a single point. The same principle used in Gothic cathedrals. The same principle used in modern reinforced concrete, arrived at independently by engineers working with hammers and chisels in the 1630s. Now look up, because the dome is where the story gets truly extraordinary. Rising 58 meters from base to finial, the Taj Mahal's central dome is not one dome, it is two. An outer shell gives the structure its iconic silhouette and towering visual presence. An inner shell suspended below it forms the actual ceiling of the tomb chamber. Between them sits a hollow void. This double shell design is breathtaking in its cleverness. The outer dome can soar dramatically without making the interior feel cavernous and cold. More importantly, the hollow gap massively reduces the dome's effective weight, limiting the downward force transmitted to the drum beneath it. The geometry was calculated using Islamic mathematical principles of arch compression, ensuring that the dome's outward thrust travels down and outward through the walls and into the plinth, not inward, which would cause collapse. Engineers today model this kind of load distribution with sophisticated software. The Mughal team did it with geometry, intuition, and centuries of accumulated architectural knowledge. But perhaps the single most quietly brilliant detail in the entire complex is something almost nobody notices on their first visit. Look at the 4 minarets. Each one leans, very slightly, almost imperceptibly outward, away from the central mausoleum. This is not a mistake. This is not settling or subsidence. This was designed that way from the beginning. If any minaret were ever to fail structurally, from earthquake, from flood damage, from any catastrophic event, the lean guarantees it falls away from the tomb rather than onto it, a fail-safe mechanism built directly into the architecture. These engineers were not just solving the problems of 1632, they were designing for failures that might occur in 1800, in 2000, in 2400. That level of forward thinking embedded in stone is almost incomprehensible. The materials chosen for the project were themselves a logistical operation of staggering scale. The white Makrana marble came from quarries in Rajasthan over 300 kilometers away, transported by river barge and by a specially built elephant road, more than 1,000 elephants working in coordinated teams. That marble was chosen not only for its beauty, but for its exceptionally low porosity. Water penetrates it very slowly, a critical property for any structure spending 4 centuries next to a flooding river. The semi-precious stone inlays, lapis lazuli from Afghanistan, carnelian from Arabia, jade from China, turquoise from Persia, were set using the pietra dura technique, which effectively seals the marble surface and reduces moisture penetration even further. Every aesthetic decision doubled as a protective engineering decision. There was no wasted choice anywhere in this building. Quality control across 22 years of construction was relentless. Plumb lines, water levels, and straight-edge tools were used continuously to ensure every surface remained geometrically perfect. The entire complex is aligned along a single central axis, from the main gateway through the reflecting pool to the mausoleum itself, to within fractions of a degree. Maintaining that precision across a workforce of 20,000 people for over 2 decades required a management system of extraordinary discipline and sophistication. 400 years later, the results speak in a language no argument can challenge. The foundation wells are still functioning, the timber raft is still preserved by the same groundwater the engineers counted on. The structure has settled by measurable amounts, but remarkably small ones, a testament to the accuracy of load calculations made without a single computer. The Yamuna has flooded hundreds of times. Empires have risen and collapsed around this building, and it stands, unchanged, unbowed, exactly where those engineers placed it in 1632. The Taj Mahal is not just a monument to love, it is a monument to what happens when human beings refuse to accept that something cannot be done. Beneath that glowing white marble is a forest of stone wells, a raft of eternal timber, and 400 years of calculated genius holding everything in place. The river has tried, the river has lost, and every single morning, when the sun rises over the Yamuna and that marble turns gold, the building wins again.